Welcome to this explainer. Today, we're diving right under the hood of Edge. It's a revolutionary tool that is completely transforming how we measure and design green buildings for the future. We're going to be looking at something that perfectly merges architectural design, building physics, and global sustainability. So, let's dive right in.
When you look at massive skylines expanding across the globe, the need for resource efficiency is, frankly, absolutely undeniable. Every single one of those towers consumes just vast amounts of power, water, and materials. And that is exactly why the World Bank stepped in to create a scalable, global solution. We really needed a way to standardize green building on a massive scale. And well, that's exactly where the EDGE standard comes into play.
Here's our agenda for today. First, we'll meet the EDGE program, then we'll look inside the design tool, explore the base case versus improved case, dive into the math behind the model, and finally, we'll wrap up by understanding virtual energy.
Section 1. Meet the EDGE program. Let's start by defining what EDGE actually is. The acronym stands for Excellence in Design for Greater Efficiencies. It's a World Bank product specifically created alongside the International Finance Corporation, or IFC. And you know, this isn't just some academic exercise. This standard brings the absolute latest knowledge, incredible credibility, and a really sharp investment focus. It was designed to showcase green projects to a global audience, proving to investors that a building is genuinely resource efficient.
To actually grab this global certification, your building has to hit a magic threshold, a 20% reduction across three very distinct categories. You're going to need 20% savings in energy use, 20% savings in water use, and a 20% reduction in the embodied energy of your building materials. Now that last one is absolutely crucial. It means looking at the energy it took to manufacture and transport the concrete, steel, and glass you're using, not just the energy the building consumes once it's fully turned on.
Section 2. Inside the design tool. Okay, so how do we actually prove those 20% savings are happening before anyone even breaks ground? Well, imagine you're designing a hospital, a hotel, or maybe a massive retail space. This incredibly powerful software provides predictive modeling and analysis right from the conceptual stage. You literally do not have to wait until construction is finished to find out if your building is green. The dashboard allows architects and engineers to instantly see how their specific design choices impact those required efficiency thresholds.
This all builds into a highly comprehensive toolkit. The software integrates incredibly specific data, pulling in local utility costs and climatic conditions for your exact location. Then, it combines that with real-time building physics calculations to give you customized design guidance. You can select multiple technical measures, like say, changing the window-to-wall ratio or adding reflective roof paint, and instantly see the investment planning results. It tells building owners not just how much energy they'll save, but exactly how fast their efficiency investments will pay off. It's a real game changer.
Section 3. Base case versus improved case.
To calculate a 20% savings, you obviously have to ask yourself 20% compared to what? The core methodology powering this tool relies on a very relatable concept, the before and after comparison. The software continually compares a standard, localized base case building against your project-specific improved case. That base case is built entirely on current standard practices or local building codes for your specific city. The improved case? That's your actual design, updating in real time as you pick different efficiency measures. And hey, if you don't select any measures at all, the two cases are exactly the same, and your savings are a big, fat zero.
But here is the kicker. How does EDGE make sure this comparison is actually fair and scientifically sound? They use a predefined geometry constraint. This means the exact same physical shape and building orientation rules are used for both the base case and the improved case. You can tweak all the internal variables you want, you can adjust the windows, add external shading, but you can't cheat the system by comparing a highly optimized building shape against a fundamentally inefficient baseline shape. It's a strict apples-to-apples comparison.
Section 4. The math behind the model. All right, let's step even further under the hood and look at the actual physics calculations. When evaluating a building's HVAC demand, its heating and cooling needs, the creators of EDGE faced a really difficult choice. They had to balance two extremes. On one end, you have the steady-state model. It uses long-term averages, so it's super quick and simple, but it completely ignores dynamic variability, meaning it has pretty low accuracy. On the other extreme, you have dynamic simulation. This does hour-by-hour simulation, so it's highly accurate, but man, it's incredibly complicated and time-consuming.
So what did they do? They chose what I like to call the Goldilocks solution, the quasi-steady-state model. Based on rigorous European C and ISO standards, this monthly calculation method perfectly combines empirical simplicity with high accuracy. It's way better than the steady-state models, but more importantly, it completely eliminates the need for expensive, highly skilled analysts that dynamic simulations demand. This makes the assessments quick, cost-effective, and highly reproducible, which, if you think about it, is exactly what you need if you're trying to scale a green building standard globally.
Section 5. Understanding virtual energy.
Finally, we've got to demystify a highly counterintuitive, but honestly brilliant, piece of jargon used in these thermal calculations. What happens if your building design doesn't even have an air conditioning or heating system installed yet? You might logically think, well, my energy use for HVAC is just 0, right? But EDGE actually calculates something called virtual energy. This is the amount of energy that would theoretically be required to reach standard human comfort levels inside your building, assuming those systems were installed at a later date.
Interestingly enough, this theoretical virtual energy is actually credited as energy savings in the system. Why? Well, because EDGE actively wants to reward inherently efficient bioclimatic architectural design. If you design a building that naturally stays cool without AC, you get credit for the energy you're avoiding. However, the software makes sure to remind you this virtual energy won't actually reduce your current utility bills, simply because the HVAC system isn't installed in the first place. It's just a really clever way to measure structural thermal performance completely independent of the mechanical equipment.
We're going to leave you with this final provocative thought. We've seen how this platform uses robust data, strict baseline comparisons, and that clever quasi-steady-state math to accurately predict efficiency before a single brick is even laid. So, if understanding our environmental impact is as accessible and mathematically sound as this tool makes it, what is stopping every new building across the globe from finding its edge? Thank you so much for exploring this fascinating standard with me today.